So far in class we've been talking about factoring, and we have seen a bunch of two different types to factor. We've seen factoring out of GCF. We've also seen factoring using the X method, which is the inverse of double distributing. Last class we created a flow chart on how to factor and how we should always factor. And when we factor, we always want to start out with taking out a GCF first and then doing the X method with the leftovers. So let's review here for just a little bit. Make sure you have a piece of paper and you're copying all of this down. So let's review. If I can write, let's see here. Let's review. So on your piece of paper, I want everybody to solve this problem. The directions obviously would say factor. When you see the word factor, you should immediately think there are answers in your parentheses. So, first question you have to ask yourself whenever you have to factor is there a GCF? Does x squared, 5x, and 6 all have a number in common? No. So on my flowchart where it says no, I got to do the X method. So I put 6 on the top, 5 on the bottom. I need two numbers that multiply to get me 6, but add up to equal 5. 2 and 3. So I have x plus 2, and I have x plus 3. Alright, let's look at another one. 6r squared plus 24r plus 18. Again, the directions say factor. When you hear the word factor, what should you immediately think? Parentheses are in my answer. So, where do I start? What's the first thing I always ask? Is there a GCF? Does this problem have a GCF? Yes. What is it? It's 6. So I'm going to divide everybody in this problem by 6. So I'm left with r squared plus 4r plus 3. Am I done? No. What do I have to do now? Well, I have to do the X method with the leftovers. So draw the X. 3 goes on the top. 4 goes on the bottom. I need factors of 3 that make 4. 3 and 1. So I have r plus 3 and I have r plus 1. If I circle this as my answer, I lose a point because I cannot forget to include my GCF in my final answer. So what if I had a problem that looked like this? 2x squared plus 11x plus 12. And the directions said factor. First question you'd ask yourself is what? Do I have a GCF? Do you? 2, 11, and 12? Nope, I do not have a GCF. Notice, how does this problem look different from this problem? Well, notice this X method only has worked when your leading coefficient, when that number in front of your variable squared is 1. Notice in this equation, I have a number in front of my variable that's greater than 1. So that's my goal for today is, okay, fine, how do I factor when I don't have a GCF and I have a number bigger than 1 as x squared? So that's the big question for the day. How do I factor when the leading coefficient is greater than 1? How do I factor when the leading coefficient is greater than 1? Well, I'm going to do the slide and divide method. I'm going to use the slide and divide method. All right, so let's look at that example that I wrote down originally. Factor 2x squared plus 11x plus 12. Whenever you see the word factor, you immediately think parentheses. You then have to ask yourself, okay, what is the first question I ask myself? Does this problem have a GCF? No. So, because I have a leading coefficient, I'm going to circle that leading coefficient, and I have to use the slide and divide method. So here's how you do it. I'm going to take my leading coefficient, and I'm going to slide it to the back. I'm going to make my x. When I slide 2 to the end with 12, 2 times 12 makes 24. 24 is now at the top of my table. I'm sorry, is at the top of my x. What number always goes on the bottom of my x? The middle term, which is 11. So now, I want to think about factors of 24 that add up to 11. What are they? 8 and 3. Here, you used to be done. But I did the slide of slide and divide. I now have to divide. So I'm going to take my leading coefficient that I circled, and I'm going to divide each of these numbers that I have on the sides of my x by 2, and I'm going to clean them up. So 8 over 2, that makes 4. Circle it, I'm done with that side. 3 over 2, can I clean it up? Nope. Circle it. So I'm now going to write my double parentheses just like before. And I'm going to write x plus 4 and x plus 3 over 2. Now, when you factor, you can never have a fraction. So notice this is a fraction. So when you have a fraction, you're just going to take your denominator. I'm going to take my denominator and I'm going to bottoms up. I'm going to move it up there next to x. So I'm going to take 2 and I'm going to move it bottoms up next to x. So it becomes 2x plus 3 and 4 plus x. And I'm done. Slide and divide method only works when you have a number in front of x squared that's greater than 1. You slide it to the back, that's the number on the top. The number in the middle stays the number on the middle. You find those factors, and then you got to divide by whatever that number you circled is. That's why I circle it, so you remember to also divide. You're going to always forget to divide. So if you want to, when you have to write slide, do slide and divide, I would write an S and a D on your X. When you slide, cross out the S because you did it, and then your brain will remember that you have to divide, so you won't accidentally forget that step. Let's look at another example. My directions say factor. Let me flip my problems here. Let's do this one. 4x squared plus 21x plus 5. So when you see the word factor, you should immediately think parentheses. All right, so first question you ask yourself, is there a GCF? 4, 21, and 5. Nope. So now you have to ask yourself, what the x method, can you do it the normal way, or do you have to do slide and divide? I have to do slide and divide because I have 4 in front of x squared. So I'm going to slide 4 to the back. That's the number on the top. Factor, and then the number on the bottom is the number in the middle. I now need factors of 20 that add up to 21. Well, 20 and 1. So I slided, I now have to divide. So I'm going to divide both of my numbers by 4 because that's the number that's circled. Clean up. 20 over 4, 5. 1 over 4, can I clean it up? Nope, circle it. I'm now going to write my double parentheses. I have x plus 5, x plus 1 over 4. I can't have a fraction, so I got to do bottoms up. And I got to move 4 next to x. So x plus 5 and 4x plus 1. It does not matter if 4x plus 1 came first or if x plus 5 came first. All that matters is one parenthesis has 4x plus 1 and the other parenthesis has x plus 5. If I wanted to check my answers, I would double distribute. You only want to do the slide and divide method when there is not a GCF and when there's a number in front of x squared. So let's try another one. Let's do this one. 5a squared plus 24a minus 5. I want you to pause this video and I want you to try this one on your own. When you finish, unpause, and then I'll go over it with you. So my directions say factor, so the first thing I have to ask myself is there a GCF? Which there's not. So now I have to ask myself with my x method, am I doing it normally or am I doing slide and divide? I'm doing slide and divide because I have a number in front of a squared. So I'm going to slide 5 to the back. I get negative 25 on the top, and I get 24 on the bottom. Factors of negative 25 that make 24. Well, 1 and negative 25. Am I done? Nope. I now got to divide by 5. So that becomes negative 5, and that becomes 1 over 5. So I have a minus 5. And then if you don't want to have to write the fraction like we did up here, and you just want to immediately remember the denominator goes next to the variable, you can also do that. So I would have 5a plus 1, and I'm done. If I wanted to check my work, I'll check it in blue. A times 5a is 5a squared. A times 1 is a. Negative 5 times 5a is negative 25a, and negative 5 times 1 is negative 5. I'm not going to draw my slashes and combine like terms. I get negative 24a minus 5, and this is exactly where I started. Let's try this one. Pause this video. Try this problem on your own. When you finish, unpause. So this problem, first question you ask myself is there a GCF? No. So now I gotta ask myself, X method or slide and divide? Slide and divide. Negative 24 goes on the top. 3 goes on the bottom. Factors of negative 24 that make 3. Negative 8. Nope, that doesn't work. Ooh, I messed up. That's why. It's not supposed to be 3. It's supposed to be negative 2 on the bottom. So, negative 6 and 4. Am I done? Nope. I got to divide by 3. Clean it up. Negative 6 over 3 is negative 2. I circle it so I know that's my answer. 4 over 3, can't clean it up. Sometimes you can clean up this fraction. You can simplify it. If it was like 4 over 6, I could clean it up to 2/3, but 4 over 3 I can't clean up. So my final answer is x minus 2, and then I'm going to bottoms up in my head, 3x plus 4. If you can't bottom up in your head, that's fine, just write it down. I have a lot of students ask me, am I always going to have at least one fraction? Yes. If you don't end up with one fraction, I'm going to tell you, you accidentally did it wrong. That means the problem probably had a GCF. So just keep that in mind. 2 more. Try this one. 2d squared plus 12d minus 80. Pause this video, solve this problem on your own. Don't let me trick you. And when you finish, unpause it. We'll go over it. First question you should ask yourself, is there a GCF? Yes? Divide everybody by 2. So I'm left with d squared plus 6d minus 40. Now, I have to do the x method with the leftovers. Can I do the x method, or do I have to do the x method with slide and divide? I can just do the x method because there's no number in front of d squared. So negative 40 and 6. Factors of negative 40 that make 6. Up 10 and negative 4. Do I have to divide these numbers? Nope, because I'm not sliding and dividing. So d plus 10 and d minus 4. If I circle this, I lose a point because I don't want to forget my GCF in my answer. So notice this problem was quicker to solve than slide and divide. You always want to find a GCF first because if there is one, you really want to take it out before you attempt to do slide and divide. Otherwise, you're going to get the wrong answer. We're going to do one more question on the notes, and then we're going to be done. We're going to do 9x squared minus 1. Directions say factor. Does this problem have a GCF? No. So I'm going to do the x method. But notice what looks funny. The middle term is missing. So I got to add my middle term of 0 in. So with my x method, can I do it quickly, or do I have to do slide and divide? To do slide and divide. So negative 9 comes on the top. 0 goes on the bottom. Factors of negative 9 that make 0, 3 and negative 3. I now have to divide by 9. So notice here, 3 over 9, I can simplify to 1/3. Negative 3 over 9, I can simplify to negative 1/3. So, bottoms up, 3x plus 1 and 3x minus 1. And I'm done.